Evening everybody. Well, another day, another repair. Although we do try to do more than one a day. Okay, today we have got a big 2485 and this one is having problems with power, as in we'll get 5 volts but it's not really charging. There is some degree of intermittent behavior apparently according to the customer, as in sometimes it looks like it's charging, sometimes it doesn't. I really don't know what to expect. Given that it's got 5 volts, we know there's some sort of activity with the CC lines, but beyond that, your guess is as good as mine. Alright then, well, guess I better get it open, get to it, see what we can do. We've got a little bit of a dust fest in here, so we could be looking for corrosion. Battery pack seem okay. It's got enough dust and trash in here that this could well be a corrosion issue. Not really a lot that I can test from here. I think it's definitely just take it out and see what we can find. We've got some markings here. I can't tell if it's liquid or something else. It does not look like it's been disassembled. None of the little plastic pull tabs seem to have any folds in them or have lifted off. So it does look like we are blessed in having been the first people to open this up and have a look. Alright, let's get the board out and see what we can find. Before I take the board out, I've disconnected the battery. I'm going to check to see what the PP bus resistance is like. We might be lucky, we might have a short. Okay, we're not registering a short, it's not screaming, but if you look up there you'll see that it's 16 ohms, and that is a little low for the PP bus. So we do have a short, it's just that it's a soft short. So yes, we're going to take the board out, have a look. We might have corrosion or we might have a blown tantalum cap or something like that. Some people by now are probably going, oh no, another cap short board, you know, so these videos are getting a bit boring. But realistically, these are the type of jobs that you want to try and get as a repair shop. You don't want the technically advanced digging into the signaling of the various chips to the PCH and things like that, because they're going to suck up a lot of time. This is about doing repairs that are going to be able to give you a reasonable margin of profit without taking up all of your time. Anyway, let's get this out before I chew up all my time with telling you about these sort of jobs. Please don't use pliers to try and get these screws out. Okay, I've seen people using these to try and turn out these screws. Use a metric 4 socket. Okay, just get a Wera or hell, any brand, so long as it's 4mm socket to get this out hex. If you use pliers, one day, sooner or later, you're going to be doing that and you're going to slip and you're going to crack the NANDs, okay? Just a warning. $5 for a reasonable socket. It's going to save you a lot of drama one day. No apparent explosion marks down there. Sadly, nothing jumping out at me, so under the microscope we go. Alright, I can't spot it visually, so looks like we're going to have to do an injection. But I want to work out what we're going to be looking for. So let's call it 17 ohms. P equals IV. Now, I don't want to inject more than, say, 1 volt. So we have current equals V on R, so 1/17th, and then power equals IIR or I squared R. So we got 1/17th times 1/17th times 17. So we've got 1/17th of a watt at one. It's not going to be much. Right, so this is going to be potentially a difficult short to find because it's about 17 ohms, which if you're trying to be safe in your injection, you don't want to go above about 1 volt at the best of times, because particularly with the PP bus, because you don't know if maybe that short is going through to the CPU or the GPU or some other like 0.9 volt rail, things like that. Hell, you should even start really at 0.5 volt and see where you go. This is an example of what I was telling people when I was getting comments saying, why don't you just inject and find the short really quickly? It's like, because it's not always a way to get a bright indicating mark on where on the board the short is. When you sort of get beyond about 10, 12 ohms, you have to inject too much voltage, or you have to apply too much voltage to get the amount of current to flow through to get the amount of power you want for that particular shorted part to show up on the infrared camera. Now, in a sufficiently cold room, a 1 volt 1 amp situation, or 1 volt situation really, because we're only going to be applying 1 volt and we're going to have very little current coming through on that, so we're basically 1/17th of an amp, and so that's not going to be a lot of power being generated in that short. Now we can try it and see what the infrared picks up, if anything. If we're really lucky, it will be a part in the open clear and it will immediately just start to show itself outside of the noise, because 70 milliwatts or so, it's on the borderline of what a lot of these cameras will pick up outside of the noise itself. We'll give it a shot. Don't have the greatest of hopes. We may end up having to go back to just visually trying to check things. Alright, a quick check at say 0.8 volts, see what we get. 34 milliwatts, it's not a lot. Alright, let's get the infrared camera. Actually gonna have to kill the lights. We're gonna have to blanket it. Alright, what do we got there? Unfortunately that is just a reflection. I hope it is. One way you can tell is you turn off the power. And it's still persisting, so that means yes, it was a reflection. Alright, I think we just might have spotted up the top right. Or it could be a hole. I think it's that middle speaker amp maybe. I'm thinking around about there. Yeah, that's definitely holding its own against the noise. Turn it off. Yep, that's what we're looking for there. Alright, let's take a look. Oh, and there it is. Yes, you can just see it there. Wow, how I did not notice that the first time around is... I don't know, I'm disappointed in myself. But I'm gonna guess it's that cap with a little bit of corrosion on it. I gotta tell you, I'm not seeing a fracture line there, but I'm gonna assume it's it. It's either the cap or maybe it's its neighbor. I suspect it's one of these two. Let's get them off one by one and see when our resistance improves. Now I am going to protect these tantrum caps next to it. The trouble with those tantrum caps is that when they get a little bit too hot, they have a bad habit of just making a silent little pfft, and they release toxic fumes and then all of a sudden stop working properly. So I'm going to do one at a time here, although both need to be removed. But I want to know which one's which. Right. So this is contestant number 1. Let's see what the resistance on those pads are now. Okay, they'll be ground. And we're sitting at 22, so that's a hot value, which means this cap likely is not the faulty one. That's an open circuit, so it's not that one. Alright, contestant number 2. Again, you look pretty innocent actually. Okay, 24, so neither of those were actually the faulty ones. So it could be the controller itself, or it could be a cap we haven't looked at yet. We just suspected these ones because they had the corrosion marks on them. What we're going to do, rather than just ripping off parts that we aren't sure of, I'm raising the voltage up to 1.5 volts, but setting the current limit to 100 milliamps. So that sets my total power potential to 150 milliwatts. And that way, if for some reason I've overlooked something and this heads towards the CPU or whatever, then 150 milliwatts is just not really going to have the amount of power to destroy things, or at least I hope not. But it should be enough to bring up who the culprit is amongst this area when I do a little bit of an alcohol swab. Okay, so we're dealing 100 odd milliwatts here, so that's good. Okay. Honestly, your guess is as good as mine. I think it's that one that we didn't take off. You're annoying me now. It might be this controller down here. No, looks like I've got to go back to thermal camera. That's annoying. Try to get a finger orientation for alignment. It's pretty close for alignment off the finger. Okay. It is the controller. Alright, so it's this middle controller. That'll explain why nothing really showed up when we looked at those caps. Because it wasn't the caps. To be fair, they were corroded, or they are corroded, so no harm in removing them. But it does explain why the caps seem perfectly good, and another reason why I stopped just pulling caps, because I thought, this doesn't seem quite right. Fortunately, there's absolutely nothing on the other side of this board. We can see that corner area is somewhat browner and different. So this here is the area where the corrosion came in. So we saw the dots of corrosion on the caps here, and then there was corrosion under here. Now, that corrosion could have come from a multitude of things. There could have been a speck of trash that came in. We did see that there was dust and things like that in the case. So it could have been a speck of trash, or it could have been bug, but I'm thinking this one was more of a speck of trash that came through. Alright, we'll remove this. We'll clean these pads up, find ourselves a replacement chip. Hopefully we can find them. Oh, better check to see what our resistance is now too. That's a lot healthier. 400 plus. That's a normal PP bus. Might as well touch these up while we're at it. So they're ready for the new capacitors, because we're not going to put the old ones back on. And now we need to, I'm going to do some hot air wicking to get that out, but we're going to have to go at a different angle. I really prefer using hot air wicking rather than forced soldering iron type wicking for these sort of tight spaces. You will occasionally knock off some parts, but overall I consider it much less of a risk. Let's see if we can just push that cap back to home. We need to find out if we can find that chip on any other boards that we have, because I do not have a donor for this board. So this is a A2485 board. And let's see, we want over here, this is our chip UR730, and it's whatever this is, so we copy that, and then we go search, find a part, paste it, and try our luck. Okay, so we have our list of boards that have this chip that we're after, and it just so happens that I do have 2536 boards. And these are for the M2 air, the new type of air, the A2681 I think it is. So what do we got? 6600, 63. Alright, so here we are. There's our two chips. Alright, looks like we'll be able to save this one today. Okay, so this is our 2681. I really hate destroying working boards. To be fair, these are iCloud locked, but I still hate it. I don't know what it is. It's just like it's against my religion or something. I don't know what. But I loathe and detest taking parts off a working board. Even if it's iCloud locked, there's just something wrong, intrinsically wrong with destroying a board. But this is why you buy them. You buy them so you do have parts on hand. Otherwise you have to wait weeks or more for AliExpress to come to the rescue. And sometimes AliExpress coming to the rescue is not really coming to the rescue. It's just going to be another drama. Okay, so we're going to get these shields off. I don't care much for this new shield technique. I can be a little bit rough on this one, I suppose, because this is a donor now. Still don't like it. And I can immediately see our two chips are down here. Oh, do we have two more over here? That's useful if we have another two. Let's see, 700. What are they? 1277 Booyah. Okay, so we actually have 4 on this board, which is good. That's nice. Means I've got 4 chances of getting one. I'm sorry, little board. I really do feel bad about taking parts off these boards. The reason why I like these boards is because they are working boards. They're iCloud locked, but they are working boards, which means you can get all your diode mode values and things like that off them and make component measurements and all that sort of stuff. But yeah, it's a cheaper board. You didn't have to buy a machine in order to get one. Just because it's a donor doesn't mean that all parts other than the one that you're taking are worthless. So assume that you may need any of those parts anytime in the future. Treat it like a normal board for this sort of situation. And see, no damage to the connectors, so that's a good thing. Okay, so we need to re-ball this. We have to be careful with these chips. These are basically like wafer chips. People who have experience with iPhones will be comfortable with making these sort of things. First thing that I do is put a decent sized blob of flux on them, and then we're going to remove that lead-free solder and replace it with leaded, just to start with. I do that using the micro pencil, like that. Nice, quick and easy. Okay, so now I just need to clean that up, and then we can re-ball that. It doesn't matter that there's some unevenness of the balls there that you can see at this point. Yeah, it almost looks like some of them are balled. That's fine, because when we go over with the stencil and put our own paste on there, it's going to even out. Now, we don't have a stencil specifically for this chip, but I'm sure we'll find one that has matching grid pattern. So what have we got? We've got 5 lines there. We've got 5 and 5 here. Look at that. Straight off the bat, perfect. Now, I might have some really crusty old paste here. Believe me, when I tell you this is crusty and old, it's crusty and old. This has probably been sitting on my bench for a week now. Yeah, it's actually almost... might just be able to get it to... That's a little too dry, folks. I think it's time for that batch of paste to be put to rest. We'll do the job this time, but yeah, I think the 2-week mark is probably where it ends. Okay, so we're going in at 270 and 15% air. These particular stencils, this is an iPhone 8 stencil. They're nice because they're actually a compact stencil. There's not it's not a lot of physical area on it. So when it does buckle from heat, it doesn't go very far. Okay, they look a bit uneven, but that's okay. Tiny dab of flux. Okay, 2 small dabs of flux. We'll bring our heat back. Oop. I was about to say. Okay, bring our heat back, hold the chips light as you can. We just don't want it blowing away. Get those balls to reball. Okay, looking good. I might comment that this one here looks a smidge small, but overall it's well within tolerable limits here. It's going to preheat the board a little bit. It's been sitting for a while, so we kind of want to get a little bit of warmth into it so that when we put this chip down, we're not sitting there for a minute cooking the chip while we're waiting for the board to come up to temperature. Okay, that should about do it. And we're going to drop a smidge of flux. Draw that out. There we go, there and there. Looking good. Put the chip on where we think it should be. It's always it's always a little bit unnerving doing this. You can often use the other chips as a guide for your distances, so like you can see the gap between those sides. You want to get about the same there, and then the balls themselves, when they reflow, will pull it into the correct position, you hope. Start heating it up from afar. The main worry here is that as it starts to move, it might catch. Okay, we're down already. Alright, welcome to the upside of leaded solder. Things drop a fair bit quicker. Now we need to put 2 caps back on here. We'll go find out what they are and come back with some caps. Okay, so these are our caps, 3435. Having a look at here, we've got the classic 10 microfarad 25 volt 603s. Those of you who watch my videos will notice that, unlike with the previous time that I used these particular caps, these ones actually more match what Apple has used. So I'm wondering whether Apple changed their supplier or something like that and moved to one that doesn't crack as much. These should drop down again fairly quickly. Again, leaded solder there really helps. We've got ground on the left. Marvelous. Nicely settled in. Okay, let's get these disgusting injection leads removed. What a mess. clean up the excess. Really not a fan of how the boards get sullied up like this. Technically they're not at any risk or anything like that, but just visually, aesthetically, yeah, it offends me. But sometimes there's a limit to what is realistic for you to do in terms of cleaning them up. For instance, this whole speaker amp section, I am finding it difficult to be able to say this job is finished because of all the watermarks and things like that on here, and yet functionally there's really nothing wrong. If it wasn't such a risk, I'd be more than happy to ultrasonic these, but ultrasonic them is probably the last thing you should be doing to these boards. I've got to be careful because I'm going to get pedantic to the point where I myself am going to risk damaging the board, so I think we need to just leave it now. I'm just going to mark roughly where the job was done, so that if I should ever see this board again, hopefully I don't, I will know where I've been. Even though I do have records, it's sometimes good to just have confirmations. I'm just going to check that PV bus, double check everything, making sure we haven't recreated or created a new problem. 5600 climbing, that's what we want to see. Before we go through the process of putting all the screws back in, I'm going to make sure that it actually does work. Right, here we go. $20 volts, it's a good start. $3 amps, reset. Alright, okay, so it's complaining about the battery not being charged. That's fine. Let's see if it charges. I have had this situation with these before. I'll just try to switch over to the MagSafe 3 cable. We can do this for a little bit until it's got enough charge in the battery, and then... oh, there we are, we're booting. Alright, so what is going on here then? Okay, leaving it disconnected. We're going to switch over to the MagSafe 3 cable and see how that goes. Alright, that's more like it. It's actually pushing the limits of that power pack. So 4.5 amps, 20, so 80, 90 watts. It's a 96 watt power pack, so it's at the upper limit. We'll give it a couple of minutes and then we'll try boot. Alright, so a couple of minutes. Let's see if we can fire it up. Looking good. Okay, so this machine is fixed, it's charging. It's just going to take a while. It's charging from a very flat state. Very nice. Okay, there we have it. Another fixed machine, and thank goodness it was fixable. These are rather expensive units, and of course there's a lot of data on these units as well. By most people fill them up pretty quick. So it was a bit of a different one this time. It wasn't a capacitor. We had the short circuit, but it was a bit of a soft one. It was only about 16, 17 ohm short circuit, which pushed it into the area of not so easy to detect with infrared. Even after looking the board over a couple of times, I just couldn't find any sort of cracked capacitor, although I did miss those couple of spots of corrosion that were on top of the capacitors next to the actual fault. But I relented and went to the injection method, but I stayed at a very low injection level because I had no confirmation that this wasn't perhaps a shorted MOSFET for the VREGs to the CPU or the GPUs, or another important area that may only require very low voltage. So we deliberately constrained the total amount of power that could go into a short by capping the current and setting the voltage. So even at both of them max out, it's only going to be a very small amount of heat. Ultimately, it's heat in a component that kills the component more than anything else. We got lucky that once we covered the board over with the infrared camera and used the blanket dome to eliminate the external sources of other reflections and cut down on the emissivity of the various components of the board, we were able to spot out that tiny little bit of indication that that didn't look quite right, that didn't look like noise, that could be our source of heat. It was a tricky one to find. When I looked at the balls of that chip, I could see that there was a little bit of a corrosion look or a little bit of discoloration, so at that point I probably could have taken the risk to take the part off and just assume that it was actually faulty. It was interesting to note that even with about 200 milliwatts of heat going into that chip, it still wasn't burning off the alcohol to let us know, hey, I am the fault. We were fortunate using the FlexBoard View part find feature. We were able to find that we had another board in the workshop that had that particular audio chip that we needed. These boards, while they are a couple of years old now, we still don't have a lot of donors for them, so it's very handy to have a part find feature that says you can find this part on another board, and you might be lucky enough to have that. So that's it for tonight. Thank you very much for watching. I've got to go and put this thing all back together, all the screws. I'm not going to burden you with that. Thank you very much for watching. I will see you in the next video, whenever that may be. Until then, you take care. I'll catch you later.